Hello everyone, welcome to my classroom. This is Mr. Knaus, and the purpose of this video is to kind of discuss and show what my electronics 2 students have been doing as a part of a collaborative project with Miss Kirk's engineering class at Shawnee. We decided to work together on the SAGE project, and specifically the Aquaponics and biodynamic farming project, where the idea here is to develop a system that can support aquamarine life and also plant life, and to grow food, both fish as far as food goes and plants food, in a system which can be sustained in third world countries or places where growing food isn't exactly all that easy. Alright, and the electronics students decided to take on this project because they felt as though they could design a way to control the pumps in as easy as a way as possible. Okay, now the way an aquaponics system works is the fish here excrete carbon, okay, in their poo, which the plants love. Okay, so we have pumps inside the water here, which send water up, okay, through here into the system. Okay, and that water is trickling down through what we call an NFT system. Okay, so there's a constant little stream of water going through to the bottom of this. And you can see actually in here, okay, we have some plants in their roots, alright, absorbing that water as it's falling down to them. Okay, so this is soilless growing. Alright, that's one of the larger purposes of this assignment, was to be able to grow plants without any soil in as small place as possible. Alright, and then the second part of this was to try to maintain aquamarine life. You can see inside here we have about 3 little platies. Okay, and then somewhere in here there's a little algae eater. Okay, and he kind of helps us clean up some more of the mess inside of the tank. Okay, so these fish, the plants love their water. The plants take the cleaner water and they send it back into the fish tank, and then that cycle continually repeats. Now the electronics 2 students, they're charged with the project with the idea of designing a timer circuit to turn on and off the pumps. Through some reading and some research, they noticed that, gee, it might be a good idea to turn off and turn the pumps on and off every once in a while to, number one, keep the pumps working well so that they go through less wear and tear, and number two, to kind of prevent the roots of the plants from being damaged from the water. Okay, because the plant roots, they are very, very important to the success of the plant, and their roots need to be protected and shielded a little bit from that water. Alright, so what they did was they knew and had done 5x5 timer projects before now. Alright, and they decided to adapt the basic 5x5 timer to the purpose of turning on and off the pump. Okay, so here we have a 5x5 timer circuit, where out of pin 3 we have an on and off state. Okay, this is an astable 5x5 timer. Okay, when pin 3 is high or on, okay, or in this case when it's low, the light turns on. Okay, basically this produces either 5 volts on or 0 volts, high and low stages, and this happens as the capacitors charge and discharge. Okay, so the red line here represents the capacitors charging and discharging, and the blue line there represents the high and low stage coming out of pin 3. And the electronics 2 students have been working with these for well over a year now. They did it in electronics 1, but in electronics 2 we figured out how can we design with these circuits. They learned a little bit about the math involved with setting up the correct resistor numbers, the correct capacitor numbers, in order to get the timer to be on and off for a designated period of time. So the kids, they design a 5x5 timer circuit which is on for 30 minutes and off for 30 minutes for the plants, just to kind of get started. Alright, so here is what the circuit would look like in real life, alright, without any kind of casing or anything. And then that pin 3 sends a signal out to a relay. Alright, now this is a single pole, or I'm sorry, it's a double pole, double throw relay. And what we did to this was we soldered wires to the end. These 2 wires on the end here is where the 5x5 timer chip would send its high and low state. And then we took an extension cord and we spliced it, cut it in half so that electricity is on and off or cut off through the relay. The relay acts as an electromagnetic switch. Okay, so when there's electricity going to it, the switch is on, or when there is no electricity going to it, the switch is off. Alright, so this is essentially now just a really fancy light switch. So the kids, they decided, you know what, we can put this in front of a power strip or a pump, turn on the 555, and that will send a signal to the relay to turn on and off the switch. So this is what they came up with. They decided to pack it all inside a nice little compact box. It receives 120 volts from a wall. Okay, and then it turns on and off the pumps. Now, there's a few little redesigns that they would do to it. Okay, one little redesign is they forgot to account for the supply. The 555 needs 9 volts to actually power it. So if they were to redesign it one more little time, they would supply 9 volts to these leads in order to keep all this in one. Right now we need an extra power supply. Alright, and then the other thing that they would do to it is to maybe make it so you had variable timing. Okay, add in some potentiometers to control and turn on and off the timer as frequently or infrequently as possible. So right now actually we just saw the timer go off. Okay, so now we have the lights off, there's no more water coming out of the pump. Okay, and it'll stay off for about a half an hour. Alright, now I'll reset this real quick by unplugging the power supply, turning it back off, and we'll turn it back on, and you can see now the system is reset and it's back on. Alright, so they did a great job with this, and it was the first time we did this in electronics, and it really turned out well. Hope you guys enjoy it.